let's start the class today. And today and the next week we will have midterm exam, okay? And the exam will be multiple choice. Yeah, so very simple. So if you take the pop quiz, it's very like the pop quiz problem. So it's not very difficult, but you must study the materials. Okay. Okay. So in the next two lectures, we are going to talk about source management and construction risk assessment. And I'm going to talk about the international perspective this week, and talk about the Taiwan CRA system for the following week after the midterm. Okay, so that's my plan. So today we have two objectives to achieve. First, I would like to understand the definition and concept of risk management, and then the basics of international risk assessment practice, taking the Australia's risk management code of practice as a benchmark. Okay. And here is the outline for the class of today. At first, we will talk about a little bit about the risk and how dangerous construction industry is. Then we will move to the basic concept of risk management, give you some definition and the method used for risk management. And then we will move to international perspective, using Australia's regulation and code for risk assessment as a role model. Finally, I will give you a conclusion. Okay. The construction industry has the highest occupational hazard risk among all industry worldwide. Okay. Not only in Taiwan, but also in other countries, such as United States. The construction industry only hire 5% of workforce, but they contribute 20% of the occupational fatal accidents. So here is the number in 2019. Among the 5,333 recorded fatal injuries, 1,075 comes from construction industry. So making it the most dangerous industry among in the country. And this is even more worse in Taiwan because the construction workers account only for 8% of the workforce, but you can see it contributes more than 50% of occupational fatalities annually. So this is the same. The situation is the same, but the severity is a little bit different among different countries. But construction is the most dangerous industry compared with other sectors. Okay, so here is the figure of Taiwan. I think I saw this to you before, right? This is the yellow part is construction fatality every year. From this is 2012, I think, to 2020 about. So you can see that every year the total fatality may fluctuate higher and lower, but the percentage of construction contribution usually accounts for almost 50%, or even worse. In this year, it accounts for 53%. Okay, so from this figure, we can see that if you can control the risk of construction accidents, you can improve half of the occupational safety for the country. Okay, so that's the reason why safety management in construction industry is so important. Okay, so what's the risk management? Risk management is the method of implementing safety management from the source. So that's the reason why I named this lecture source management for construction safety. And it has many aspects of importance, including reducing the likelihood and the severity of adverse events, making the work safer, workplace safer, and bring financial benefits. If you don't have accidents, then it will improve the performance of schedule, progress, or quality. Then you will return with the benefit, financial benefit to the construction firm. Okay, and it can save time and efforts. Once there is a fatality accident, then the construction site will be closed at least for how long? Do you know how long? How long? In Taiwan, if there is one fatality, usually at least 1 month closed. 1 month at least, which means that sometimes if the whole thing is required, then it can extend the time for the construction site closing. Okay, so it has very significant impact on the time and the effort spent by the construction firm and the project, and so it can preventing the business loss and promote safety culture, of course, and finally can guide the decision making for the top management. So in today's class, we are going to talk about what's the essence of risk management in section 2, okay? And in section 3, we are going to take Australia as a model to learn how to perform risk management for construction industry. Okay. Okay, so let's talk about the basic concept of risk management. First of all, what is risk in your mind? Have anybody have some idea what is risk?
It's danger. It's damage.
Mm-hmm.
It's damage for somebody.
Possible what? Possible event.
Hidden danger.
Hidden danger, right. More precisely, is uncertain danger. If you know there's a danger, then it's not risk. No, if you know the accident has occurred, then it's a loss, not a risk. So when we talk about risk, there is a very essential characteristics of uncertainty, which means we are not sure if it will occur or not, and we are not sure how much it will impact us. Okay, so in the project, anything that may occur at any time and impact the outcome of project execution is referred as a risk. So this may be an uncertain event or uncertain condition. Okay, for a construction accident is an event, right? And for something like the increase of the market price, then it is another thing. It's not an event, it's a condition. Okay? So this event may or may not occur, which means it's uncertain whether it will occur or not. Okay? And if it occurred, it will impact the execution of project. But we are not sure how much it will impact the outcome of the project execution. Okay? So the event can be positive event or negative event. Can anybody give me examples of positive events for construction project? Like what? Sunny day. Okay, good. And what? Yeah, we have a raining day. Raining day is negative, and sunny day may be positive. Any other example? Like you are bidding for a project. You are not sure whether you can win the project, win the bidding or not, right? So if you consider the winning possibility of the project, that is a positive risk, okay? And I think you have many examples for negative risk, like construction accident, like increase of market price for the materials, or maybe the shortage of workforce, like Taiwan now, okay? So the positive event or condition or positive risk is usually refers as opportunity, and the negative ones are called threats, okay? So there are many positive and negative risks in construction project, but in construction project management, we usually only manage the negative one. We usually don't spend time on positive one, okay? So what is the risk? There is a formal definition for a risk in the national standard in Taiwan, 31,000. It defines the risk as the effect of uncertainty on objectives. And here are three important elements in this definition. First is objectives. What is objective? Objectives is outcome of activity or outcome of the project as a whole, okay? And the second one is the effect. Effects means the deviation from expectation, okay? If this event occurred, it may deviate the outcome from what you expected originally, okay? So the deviation can be positive one and negative one. So the effect can also be positive or negative, okay? And finally, the key point is uncertainty. Uncertainty means you are not sure. You cannot tell whether it will occur for sure or how much it will damage you for sure. Okay, so a risk, a construction risk or a risk event is typically categorized as a combination of these three elements together. Okay, so that's risk. But what is risk management? How can you manage risk? Okay, if you have something which is has an impact on the outcome of your project, and the outcome can be positive or negative, and you are not sure whether it will occur or how much it will impact you. So how can you do about it? How? Technology? And what else? Yeah, of course, technology can improve. Usually we have systematic method to manage something. It's called a risk. This is also applicable to countries who have conflicts, like the United States and China now has conflicts. So they are leaders, country leaders, should manage the risk. Have you heard this term? Manage the risk. which you control the risk, not allow the risk to impact the country to have a very dangerous result like a war or something like that. Okay, so in CNS 31,000, risk management refers to the guideline to regulate organization to coordinate their activity on risk. Okay, and risk management will guide the organization what to do, what actions should be taken to manage the risk. Okay, that's a definition of CNS. And another definition by PMBOK. Do you know what's PMBOK? Project Management Body of Knowledge. Is a Bible for project management published by PMI United States. Okay, it's an international organization for project management. And in PMBOK, they define risk management as establish the procedure for identifying, assessing, and planning responses to both positive and negative events in the project. So risk management means these three things. Okay? Identify, then assess, then plan responses to these events. And the objective of risk management in project management is to increase the success of opportunity and to reduce the occurrence or impact of threats, okay, by taking proactive measures. We are going to talk about what proactive measures you can take to manage the risk later in today's class. Okay, so what is construction risk management? Construction risk management is to address the threats to worker safety in construction project. It includes a process of identification, assessment, and control to reduce the risk probability and mitigate its impact. Okay, so if you talk about construction risk management, usually we refer to worker safety. We focus on worker safety. Okay. So there are three major activities in this process or in this procedure. First is identification. Okay, risk identification. Risk identification refers to recognizing the workplace hazard. What is hazard? Anybody? Threats? Dangerous thing. Yes, but it hasn't occurred as an accident. Actually, you can consider hazard as an accident, construction accident, but not yet occurred. Okay? Usually in safety management, we consider a hazard as an accident that has not occurred. But it's not only hazard to construction safety, but also hazard for the health and illness. So there are different types of hazard. But in construction site, we usually talk about safety hazard. Okay. And so in identification, we have to recognize the hazard first. Where is hazard? Where is the hazard? And their causes. What caused the hazard? And then what are the potential consequences related to this hazard? Okay. In maybe next lecture, we will talk about how to recognize this hazard and what will cause this hazard. Okay? And the second step, the second one is called assessment, risk assessment. And once you have identified the hazard, the next thing is to assess whether or how likely it will occur and how severe it will impact the construction workers' safety. Okay, so we will assess likelihood and severity of the risk to classify their label and decide whether to accept it or not. Okay, and if we find that the likelihood and severity is very high, then it is not acceptable. Then we have to take control action. Okay, so the risk control is to establish the method to avoid or reduce the risk by two means. First, we reduce the likelihood. Second, we reduce the severity. Okay, and we will talk about how to reduce the likelihood and severity later in this class and next one. Okay, here are more detailed explanation of risk management activity. First, identification. How can we identify hazard or risk? Actually, there are many approaches to do it, and this approach are usually based on experience and based on historical data, like the project report of finished project before or prior projects, and the real case study. And every construction accident will have a report, and a case study report is required. Both the owner, the supervision unit, and the contractor has to generate their own report for a construction accident. In Taiwan, that's required by law. So once there's an accident, there are at least 3 reports for the case. So in Taiwan, we have, I think, there are more than 1,000 accidents every year, more than 1,000, and about 200 will be recorded officially, but those are not recorded officially, will be kept in the files of the company. So they also exist. So there are plenty of case study report. And the hazard and their cause are identified, and not only the cause and the hazard type, but also the potential consequence or the related accident type will be identified as well. And sometimes in risk identification, we will also propose preliminary measures to reduce or to eliminate the risk event. Okay, and the second one is assessment. For assessment, we will use a risk assessment matrix. Like this. Okay, this is risk assessment matrix to evaluate and determine the risk. Two things: risk severity and the likelihood. Okay, for example, like this one. And this is the scale or criteria to assess the likelihood of the occurrence for a risk event. If this is so-called 3 levels, right? 3 level scales. For the highest level, if you use 3, it means that this activity or this event is almost certain to occur, which usually refer to daily operation of construction activities. Okay, and if you use 2 to assess likelihood, it means possible, it's immediate, certain. Okay, and it refers to periodic operations. And if you use 1, it means it's almost impossible to occur. So it refers to occasional operation. Okay, so these are the so-called 3 level scale to assess likelihood of a risk event. How about the severity? usually we also use 3 labels or 5 labels. If you use 3 labels, the highest is also 3. And the severity you try to, you refer with 3 is catastrophic event, which means at least 1 or more fatality, or 3 workers severely injured. Usually they have to be hospitalized. Okay, and if you use 2, means moderate severity, and it refers to 1 or more worker hospitalized. And if you use 1, it refers to something that negligible, okay? And it refers to 1 or more workers with minor injuries and that can be treated on site, okay? So this is the scale you use to assess severity, okay? With likelihood and severity, if you times likelihood with severity, it comes out with what? In statistics, if you times likelihood is probability, right?
Yeah.
Severity is impact, outcome. So probability times outcome is what? Expected number or expected outcome. Okay? So we times likelihood with severity, we come with so-called risk priority number, RPN. Okay? And if you times 9 times 9 equal to 9, right? And 1 times 1 equals to 1. So it will come, it will result in RPM from 1 to 9. The most is 9, the least is 1. So you will come up with this matrix. And we classify the RPM into 3 rows, okay? And for the red row, it means high risk, which means that if the RPM equal to 9 or 6, then immediate action must be taken right away, okay? And for the yellow ones, it means medium risk. Then the risk mitigation is needed, okay? For the green one, green row is low risk, which means the acceptable risk. How come? How come there is a risk which is acceptable? If it has impact to the construction workers' safety, how come it can be acceptable? Minor, it will injure, okay? Refer to the definition here, 1 or more with minor injury. Minor injury, but still has injury. So why? Why we have something which is, has risk but acceptable? Anybody can tell me? The key is cost. Cost to respond or to treat this risk. We do not have unlimited budget, right? Yeah. So you have to do something which is cost effective. Always in project management, you have to do something which is cost effective. So for something which is minor, we usually don't do anything about it. So have you heard the rule so-called Pareto diagram like this? So usually we spend 20% of our effort on 80% of the risk. Pareto rules or 80-20 rule. Have you heard about this? These rules of economy. If you want to invest your money, you you usually invest on 20% of the start, which will return, give you return, right? And so if you analyze your portfolio of your investment, only 20% will earn money, and 80% you will lose money. Yeah, that's the rule. So for the construction industry, same thing. We will spend our effort and our resources on controlling these most dangerous or most significant risk. That's the basic idea for risk management. Okay, the last part is risk response, which means we have to take action to respond the risk we have identified, and we assess and determine that is unacceptable. And if you find that there are some risk event which is not acceptable, we must take response measures. And if you want to plan your response measures, then here is a so-called hierarchy of control. Okay, there are 5 levels of control in this hierarchy. Okay, and the most effective one is the top one. The least effective one is the lowest one. So if you can do something to eliminate the risk, then you must go for it first. Okay, otherwise you will have to consider the second one, substitution. Or if you cannot do anything about it, then engineering control is our next option. And if we cannot improve by doing this, then we will use administrative control or PPE. Okay, so let me explain this. Elimination means physically remove the hazard. And we usually use the term in Taiwan, we use essentially safe, which means it was a danger or a risk to construction workers. But if we change or modify our design, then we can eliminate the hazard completely. Can anybody give me example of elimination of construction risk?
Using net in high floor.
High floor?
Using net or hook or harness.
Harness? No, that's not elimination. That's engineer control. Yeah, you all know working at height is the most dangerous for construction workers, right? Do you know 80% of fatality comes from fall from height in Taiwan. In United States, about 60%, I believe. So fall from height is the most dangerous hazard for the construction worker. So can you do anything about the fall from height and working at height? From working at height to working on the ground. Like what?
Using machine.
Yeah. How can you use machine?
Application construct.
Okay, have you heard precast concrete? Precast component. Yeah, there are some construction firms in Taiwan who are specialized with precast components of construction structures. Then the construction worker don't have to work on height to set up the scaffolding, set up the formwork, pouring concrete or lay out the rebar. Okay, they all do it in the factory on the ground. Then these components are shifted to the construction site and installed with the machine, like the crane. Yeah, that is an example to eliminate the hazard completely. Okay. Secondly, substitution. how can you substitute something which is risky to the construction worker with something which is not so risky? Usually, we modify the construction process as well. Construction process. For example, we can actually we have the example later. Let me show you the example. This one. Substitution. For working at height, we can use alternative method that allow workers to complete the test at the ground level. Okay, something like the precast concrete construction method. Okay. Then engineering control. Engineering control means that we isolate the workers from the hazard working areas, which means we set up some guide rail or covered so that the construction worker will not enter the dangerous or hazardous zone. Okay, and then administrative control, which means we use supervision, inspector or supervision unit to supervise the construction worker for not entering the working room. Okay. Finally, if all this failed, we at least will equip the construction worker with personal protection equipment. Okay, like harness or lifetime. Okay. So yeah, this is very important concept, the control hierarchy. Okay, if you can, we should go with elimination first. Then, if this is not possible, then we do with substitution. Then we use engineering control. There are so many methods in engineering control. Basically, on construction side, our measures are related to engineering control most. And these two parts are proposed by modification of design alternative. Either the structural design or the process design. And this is some temporary facility which can support the construction worker to provide better or lower risk working place. Okay, and administrative control are usually in place. No matter you have this measure or not, we usually have to provide guidance or training to construction workers, and this is also required on site, no matter whether these actions are taken or not. Okay, so this is a very important concept for risk management. Here is the example. This is specified in the Article 17 of the spec. This is for construction safety and health facility standard. Okay, and in this article, it said that for work at height exceeding 2 meters, that worker face 4 hazards. Employers must establish a 4 prevention plan, construction plan, following the risk control hierarchy. Here is the risk control hierarchy. First, the design or method selection. So there is no option for elimination for working at height. Actually, if you can replace or you modify the construction method from pour in place to precast component, then you can eliminate this risk. Or you can use alternative method that allow workers to complete their test at ground level, so that it can reduce the need to work at height. Or you can change the construction process, like this is engineering control measures, like install permanent structure like stair railing, okay, before proceeding with work at height, okay. For stairs, there's a railing, right? And usually we won't install the stair railings after the work is finished. But nowadays, usually the construction firm will install the railing first to prevent the worker falling from high when they are working on the stairs. Okay, so this is very common on the construction site nowadays. Or use PPE, provide the harness and lifelines, and administrative control, provide safety supervision system like CCTV, or provide some supervision engineer on site. Finally, they provide training to workers with safety regulation procedures. Okay, so this is an example how the control hierarchy can be implemented to reduce the risk of working at height. Okay, so here this is just some comparison of the terms used in the CRA technical guide. We are going to talk about CRA technical guide of TOSHA next lecture. Okay, and in the CRA guide, risk management is called risk management. Hazard identification is called risk identification. In assessment, we call it risk analysis and evaluation, which means you have two steps. First, you analyze the risk first, then you evaluate a risk, whether to accept it or not. Finally, is risk control. In Taiwan, we call it risk responses, not risk control. Okay, so just some terms to understand. Okay, so that's the basic concept of risk management. Any question about it? So far, so good? Good, good. Okay, so it's about time. I think let's take a break. In next class, we will talk about the risk assessment regulation and practice in Australia. Okay, so that session we talk about risk management, the concept, and how can it be implemented. There are three major activities in risk management, right? Hazard identification, risk assessments, then risk control. Okay, and there is a hierarchy for risk control. That's the key point. And then we will take a look at other countries like Australia's, or we call construction safety management advanced country. Okay, and here is this a comparison of occupational fatality rate among different countries, and the best performed country is United Kingdom. Okay, they have only 31 fatality in 2017. However, they have how many workforce? 100,000, right? 100,000, 27.3 100,000. So the so-called fatality rate per 1,000 workers is only 0.01. Okay, you can see Taiwan is almost 0.1, so almost 7. I would say 7 or 6 or 7 times higher than United Kingdom. So we usually then all the regulations, specification for construction safety were taken from United Kingdom. Okay. However, it's far away from Taiwan, the performance. And you can see the Singapore here. Singapore, New Zealand is also well-performed country. Even United States is a better performed country than Taiwan. So we have so many role model to learn. But Australia is one of the Commonwealth countries, so they have the tradition of United Kingdom. So you can see like Australia, New Zealand, Singapore, all colonies of United Kingdom in history, and they have very good performance in construction safety. So Australia is a very good model for us to take a look. So the policy for occupational safety and health in Australia start with 2002. In 2002, Australia implement so-called National Occupational Safety, Health and Safety Strategy, and we call it as National Strategy. And in this strategy, the Australia's government, business council, which means the owner part, and the trade union, the worker union, work jointly to continuous improving the country's occupational health and safety performance. And the key action they took to improve the health and safety includes to reduce workplace risk exposure. Okay, which means that if there is a risk in the workplace, then we will reduce the appearance of workers in this work area. Second, to enhance employers and managers' capability in safety management. This is what we are doing now in Taiwan. We are educating the employer and the construction manager with CRA, construction risk assessment guidelines. And they are still learning, actually. Not everyone on the construction side or in the project know about the knowledge how to perform CRA or how to perform risk management on construction project. Number three, to develop local occupational disease prevention strategy. This is another story for construction health, another safety. Number four is to minimize hazards during the design phase. This is key. Okay. Usually, in the past, we think the safety management is the responsibility of construction firm. So, how to minimize hazards should be performed or implemented during the construction phase. But in source management for construction safety, we turn from construction phase to design phase. We eliminate the source of the risk from the very beginning, okay, during the design phase. So there are a lot of responsibility being put on the designer to consider how the worker will face, how risk or how dangerous the worker will face, so that they have to modify their design so that they can eliminate the risk for the construction workers. Finally, to strengthen the government influence in improving safety outcome, which means they define or they constitute a lot of regulations and laws so that the designer, the owner, or employer who didn't follow these actions will be punished. Okay. So there are four key objectives in this national strategy. First, to reduce work related to fatality, injury, and illness. How can we reduce work like this? Construction site, we have to perform the task so that the structure can be constructed. So we will talk about how to reduce. Reduce doesn't mean to eliminate, just to reduce the possibility or the occasion that may related to fatality or injury. Or to minimize exposure, this is the means. We use a method to minimize exposure by protect the workers, by isolate the working zones, or by other means to control the exposure of the workers to workplace hazard. And to improve risk control measure, just like we mentioned in that session, there is a hierarchy for risk control, okay? And establish a revised national work health framework, okay? And there are 7 priority action areas. One of the key areas is design for safety, or health and safety by design. Okay, which means that with the means or with the measures of design, then we can eliminate the possibility of the occurrence of the risk. By design for safety, it means to ensure that the structural equipment workplace design can help eliminate or minimize hazard at the source, or incorporate the safety principles into the process, system, and job design. Job design, okay, that's the key words here. To effectively manage or eliminate the risk. Okay, that's the concept. Next lecture we will talk about how to really to implement this concept on the real world construction project or real world construction operations. Okay, and then that's 2002, right? And then in 2005, Australia introduced the national standards for construction work, and there are 4 key points. Okay, it's issued by National Occupational Commission, and then it serves as a reference framework so that there has a common or uniform national standards in construction industry. It can provide a guideline for the construction firms and the participants of the project to follow. And they aims to manage safety and health in construction industry to protect workers from related hazard, and that defines the responsibility for personnel involved in design, planning, and construction process. So not only the designer, but also the planner and the contractor. Okay, so in these standards, they emphasize on the responsibility of designer. The key responsibility for the designer includes 5 aspects. First, the designer has to identify hazards related to construction work during the design phase. And then they have to assess the extent of control over design-related risk, including eliminate the risk that can affect the workers' health and safety whenever possible. Or if elimination is not possible, then the designer has to minimize the risk through design modification. Okay, that's a very good example. You know, whenever I serve as a committee member in the construction site for audit, I usually challenge the designer about that design. So if you see in Taiwan, there are so many high-rise buildings with we call flying beams like this. Okay, have you seen this before? These beams is only for decoration. There's no physical function for it. But do you know, to construct these components can cause working at height, right? On the edge, opening edge. So it causes a lot of hazard for the construction worker. And every time I serve as a community member, I always change why you design for this. Why? It's called a vocabulary of architecture. You know, vocabulary architecture, which can symbolize the personal characteristics of the architect. So they just want to show their identity. Okay, if you see this structure with this component, that's my work. Okay, mean nothing, but it can cause fidelity. Okay, so they have to modify their design to eliminate or minimize the risk of the work, and they have to consider the construction, maintenance, the demolition safety during design phase. Which means, if you design a building, you do not only think about the risk during construction, but also during operation and maintenance, and also for demolition. This is now required in Taiwan. When you design a building, the reviewer can challenge you. Is there additional risk can be induced by this design during the operation process like this? If you design a city very high, like 5 meters high, and there is a lighting, then you have to replace from time to time, right? Yeah. Then you are required to design a method to replace this component or device. Otherwise, you will be disqualified during the design review. Okay. So this is also new in Taiwan. Okay, and not only to identify and assess or consider how to improve the risk, but also to document all these safety consideration and report them to relevant professionals, which means to report them to other professionals like contractor or professional construction management or other supervision unit. Okay, this is so-called risk transfer. Risk transfer or risk transmission. Which means you have to pass over all the information you identify related to construction safety to the other parties in the project. Okay? And the report should also detail identify risk and the extent of designers' responsibility in mitigating them. So not only identify the risk and pass this information to the other parties, but also you have to propose measures or methods to mitigate this risk. Okay, so for the designer, how do they mitigate the risk? How? They have to allocate budget for the contractors so that some safety facility can be installed, or some safety measures can be taken during the construction phase. So what they need to do is to design the temporary facility and to estimate cost required for those designs, and then they have to allocate this budget to the contractor. And then they have to allocate this budget to the in the project total cost. Okay. Okay, so in 2009, okay, that's 2005, then 2009, there's a so-called Model Safe Work Act, 2009. And here they introduce a uniform safety framework, which means they have something like the tri-level construction safety management framework in Taiwan. And this framework is applicable to all Australia jurisdictions, which means all territory in this country. And to 2011, this act is officially enacted. Okay, and if you in this act, there is a definition of the designer for equipment, material, and structure. The designer must take reasonable, practical measures to ensure safe design. So if something occurred to your design, which was due to you didn't consider safe design, then the designer will be obligated, okay? They will be punished, okay? And design should eliminate or minimize risk related to work practice, health, and safety. Special attention should be given to risk that may affect workers during using the design structure, okay? And it includes not only the principal designer, but also other designers involved in the process of design. So everybody, if you has contribution to this design work, then you are obligated to this law. Okay. Okay. So in 2011 is officially enacted. Then there's another article which defines the responsibility of the designer. They have to eliminate hazard manual work as much as possible. So try to eliminate all manual work. Manual work, which means if you can design a structure with pre-installed or pre-established, pre-erected component, then you must do so. Otherwise, the manual work has to be performed on site, and usually manual work will induce construction hazard. And if the manual work is necessary, then it must be aligned with structural equipment design. So you have to design equipment to protect the worker to minimize the risk. Otherwise, it will come with penalty of this amount. Okay, and the second part of the same article specify this. Designer must ensure that the factory and the structure design minimize eliminate the need of hazard to manual work. Okay, and they have to ensure the best reasonable method to be adopted to reduce manual handling risk. And this provision requires the designer to provide safety information related to hazard associated with the factory of structural material and ensure that the worker understand and mitigate the risk associated with manual handling operation. Okay, so it has changed dramatically from the traditional perspective. Traditional perspective usually emphasize on the contractor's responsibility for these duties. But nowadays, they have changed this perspective from the contractor to the designer. Okay, because we think that many risks come from the design itself. So if you modify the design, many, maybe 90% or 80% of the risk can be eliminated. Okay, so there's another provision for the documentation of the risk information. The first one is safety report submission. Designer have to provide a written safety report. We will talk about this is the CRA during the design phase to those who executing the design outcomes, which means to contractor. Okay, they have to provide written safety report to the contractor, and the report must explicitly state the designer's reasonable knowledge of any hazard or risk associated with the structural design. And the report must cover potential health and safety risk related to construction or certain component of the structure, and whether the design differs significantly from the other similar structure, which means that if your design is very different from a common structure, you must emphasize on this so that the contractor can pay attention to this change. Okay, and if you fail to do this, there will come with penalty with this amount. So that's the WHS regulation for the designer. And later on, the Australia published another one called Model Code of Practice. Okay, and this code is a specification for the contractor to follow. It's a legally enforceable guideline, and it provides detailed instruction to the contractor to help the workplace to meet the health and the safety obligations, such as how to handle the asbestos, or how to work in a confined space, or how to label a chemical hazard in workplace, something like that. So this is a code. Code means the specification for the workers. And they also provide support to help the members, such as contractors or designers, to comply with this code. Okay. So there are two parts in this model code of practice. The first part is self-design of structures. In self-design of structures, it provides practical guidelines of the design of for the design of structures that will be the workplace, such as the formwork, such as the scaffolding, something like that. And it applies to anyone making decision, which is the designer or employer, that can impact a structure, including permanent or temporary or movable design. Permanent means a building structure. Temporary means temporary facility. Or movable means some facility equipment which can be moved around the construction site. And these people, including the architect, the construction designers, the engineers, and other design professionals. So all these parties are considered to be relevant to self-design of structure. And recommended the systematic health and safety risk management approach, including 4 steps. In that session, we talked about 3 steps, right? And they add one more step to review of control mechanisms. So there are 4 steps: hazard identification related to design and the predicted risk. Second, risk assessment of the identified risk. And then control measures to eliminate or to minimize the risk. Finally, there is a continuous review of this control mechanism to make sure it works and effective. Okay. Okay, here is the flow chart for design safety. Okay. First, they have to establish the design context to do some site investigation, like to collect information about the surrounding environment and the construction site, and also the functionality requirement for the structure. Okay, and then they have established the consultation method with the client, which is stakeholders. So in pre-design phase, they have to do so. And then during the conceptual and schematic design phase, they have to conduct preliminary hazard analysis and consultation. And in this step, they have to identify hazards that are affected by the design of the structure and are within the control of other designers. Okay, so here are some explanation how this work can be done. Here is a detailed description of what should be done in this phase and what should be done in the conceptual schematic design phase. And finally, to the next step is design development. During the design development, the designer has to determine how risk will be eliminated or minimized through either implementing solutions from recognized standards or conducting risk assessment process. If there is identified hazard and there is a spec to deal with those hazards, then you have to implement solutions from these standards or specifications. If there is no available spec or standards to deal with the hazard you identify, then there is a systematic approach to conduct a risk assessment for the hazard which has no suitable solution in recognized standards or specifications. And then, after this step, the design risk control measure has to proposed, and the designer has to ensure the health and safety is included with other structural requirements in the design. Okay, and after this, this method or measures has to be designed, has to be reviewed, and to establish whether risk elimination or minimization has been achieved, including that control measures has not yet introduced to risk. And if all risks have been tackled and all risk level has been determined to be acceptable, then this design is finalized. Otherwise, it's not accepted. Then you have to redesign to reduce the risk within the designer's control. Okay? Okay, this is exactly how we do in Taiwan nowadays. We use this same approach for construction risk assessment. So in every design, in every project, we have to conduct and we analyze, identify the risk. In this step, then there are at least 3 stages in risk identification and assessment. And then we assess every risk you identify and to find solution to eliminate or reduce or mitigate the risk in terms of the severity or the likelihood. And then we recalculate the risk priority number to determine whether this risk has been reduced or mitigated to the level which is acceptable for the construction workers. If so, then the design is finalized. Otherwise, you have to go the same recursive iterations here to redesign your process or redesign your structural temporary facility or protection devices, then to review the design again and to assess it again, and finally to evaluate whether it is acceptable or not. And this process go until all risks are within the acceptable levels. This is the model code of practice for design risk, safety design of construction structure. Okay, this is the first part. And the second part, this is just the first part only to identify the risk and assess and to propose the measure to eliminate it, right? The second part is to really to manage the work risk, which means that we have to control or manage the risk with a systematic approach, which is identify hazard, assess risk, control risk, and review the control measures. And the method we use for hazard identification are this. Inspection the construction site, which means you have to go to the construction site, look around, inspect all the surrounding conditions, including the site geographic conditions, the weather conditions, and the traffic in the surrounding areas, etc. And then consult the workers to elicit the information from the construction worker who will to perform the work, and then refer to the supplier's manual and checking available information sources such as the risk or risk report or the accident report in the past projects, something like that. Okay, so for hazard identification, we usually use some historic data, either from government published data or from some textbook, or you go to the construction site to analyze, investigate the site by yourself. Then you acquire information of what possible potential risk can be induced. Then usually we conduct a brainstorming among the construction teams or the design teams. So it's very important to include people who has practical construction experience in the design team. You know, in many architect firms, people only do design, they don't do construction. But for risk analysis, they do need people who know the construction work, how the construction work will be performed. Okay. So these are some examples of identified hazards, such as manual work, or weight, high weight, or psychological, social problem, or electricities, machinery, or hazardous substance such as poison gas, something like that, or extreme temperature, high temperature or low temperature, or radiation, or light exposure, or something else. Okay? So for every hazard you identify for the construction activity, you must describe it, including what source caused this hazard and what consequence can occur to this hazard. Okay? And then the second step, to assess the risk. Okay? And the assessment including two parts. The first part is the severity of the risk. The second part is the likelihood of the risk occurrence. And for the severity of the risk, you have to identify, assess the type and severity of the risk, and the impact severity factors such as fall distance, concentration of specific substance like CO, CO gas, or SO2 gas, something like that. A number of people will be exposed to the hazard, and whether failures leads to immediate or delayed response effect, which you have to consider for when you are assessing the severity. And when you are assessing the likelihood of the risk occurrence, then you have to consider the frequency of the work, whether it's a daily operation or periodic operation or occasional operation. And you have to assess the degree or duration of exposure to the hazard. Okay, and the likelihood of the event occurrence, rare, active, or frequent, or effectiveness of existing control measure in reducing this risk. Okay, that's the assessment. For the control, we talk about the control hierarchy. Now, you can implement this concept for risk control. And the priority option is to eliminate the risk. And if this is impossible, then we try to substitute the hazard with a safer alternative. Okay, and to isolate the hazard from the workers and reduce the risk through engineering control, try to provide some protection equipment to that. And reduce exposure to the hazard using administrative control to educate the worker not walking into the room, or provide some signage showing that this is the dangerous form, don't walk in, something like that. And finally, we have also to provide personal protective equipment, PPE, to the workers. Okay, so that's basic idea. And finally, in this step, we also have to ensure the effectiveness of the control measures. So we have to consider accountability in occupational safety, maintenance of the equipment. Usually, this is an issue. And at the beginning of the work, usually this facility or equipment are well installed. But during construction, the worker usually, they dismantle this facility for their operation, something like that. If they want to transmit materials, they usually take off the transverse bracing of the scaffolding, and then they never reinstall them. Why? They think that I might have to transport the materials later on, so they just too lazy to reinstall them. So how to maintain the facility is a key to protect the workers from the hazard. And continuous training and capability update. In Taiwan, every day we have a so-called toolbox meeting, and toolbox meeting usually is a training process. The worker, the construction manager will tell the workers what work we will be performing today and what hazard you are going to face. Okay, and regular updates of hazard information. This is also important because construction site is a dynamic environment. Every day the environment will change, so the hazard will also change as the work progress. Okay, so they have to periodically inspect and consult the workers and the construction site to gather the most updated information for the hazard. Okay. Okay, the final one is to review the measure to make sure the measure is working effectively. So usually we have to ask whether the control measure, design, and work procedure are effective or not. Whether the control measure will introduce new problem. What construction measure can introduce new problem? New problem means new hazard. What? Give me an example. This is so-called secondary risk. Second. S-E-C-O-N-D. Secondary risk. And the original risk called primary risk. And you want to control a primary risk, you may introduce a secondary risk, right? Like what? Okay, if we want to control the primary risk of working on height, which you are facing before instant, and you provide lifeline harness. Okay, and if the harness is put on the lifeline on the scaffolding, they also can introduce other risk because the worker can be tangled with the lifeline and they can be tripled and fall down. That's the so-called secondary risk. And we do not only consider the primary risk, but also the possible or potential secondary risk. Okay? Okay, so whether all hazard has been identified or not, this is almost impossible to identify all hazard. So this activity has to be performed periodically. They have to identify the hazard from time to time every day. And whether the new regulation or method, equipment or chemical can enhance the safety. If so, then it must be applied to the risk management, risk response measure right away. Whether the safety procedure has been followed, this is very difficult. There is very situation cannot be resolved for a long time. You know, on construction site, for 100 worker construction site, there will be only 2 safety personnel, full-time safety personnel. So you cannot count on these 2 personnel. Everybody is responsible for safety procedures or safety monitoring. Otherwise, there will be blind spots everywhere. Okay. And whether safety training programs are effective, and whether the frequency or severity of safety incident decrease over time. We want to see the decrease of hazard over time, but this is usually not the case. Okay, I have been overseeing so many construction project safety programs, so they are always fluctuating higher and lower, higher and lower. And usually during the summertime or during the structural construction phase, the risk is increasing, and after finishing, the hazard decrease. Okay, so this is how we monitor the risk control measure, how we review risk control measures. Okay, we will refer to Tosha's CI technique guide and in next session, and there are the term usage difference between these 2 guides, the Tosha's technical guide and Australia's risk management code of practice. Okay, finally, the conclusion. Okay, we control time very well today. Risk management is an essential approach to proactively this is the keyword, proactive. We do not take the risk passively. We take proactive measure to control the risk, including 3 major steps: risk identification, assessment or evaluation, and risk control. And Australia has a very clear policy, laws, and practical regulations for occupational safety and health management. They explicitly define the risk management requirement and emphasize the roles of designer. They shifting the responsibility for safety management from contractor to the designer. This is big steps, big difference compared to the traditional approach. Nowadays, Taiwan adopt the same approach in our construction engineering risk assessment technical guideline. We will talk about this in next lecture. And the commitment of management, top management, is very important. So nowadays, when we are assessing the so-called construction best practice national award, we call it the Gold Safety Award for the construction firm. The first thing we have to evaluate is how frequent the top management involved in safety activity. Okay, so if they show up frequently on construction site, usually the site will be in order, in very good order, and the safety performance is good. Otherwise, the site is just chaos. Yeah, so top management involvement is the key to implement all the risk management activity or management measures I mentioned in this session. Okay, so that's all for today's lecture. Is there any questions? There will be